Hello everyone and welcome. In my previous presentation, I introduced MCP, its use cases, and why it is becoming so important in today's AI landscape. If you haven't watched it yet, I will share the link in the video description. Please go and watch. Today we are going to deep dive into the MCP runtime architecture for intelligent AI system, and we will break it down in the simplest and most practical way possible. Understanding MCP architecture is the key to building scalable and intelligent AI system, especially when it is compared with the traditional software integration approaches. By the end of this session, you will have a clear understanding of MCP architecture, its complete process flow, and how it can be applied across different AI use cases. Whether you are already working on AI systems or planning to build one in the future, this session will help you understand how MCP components interact within an intelligent AI ecosystems. Let's assume a simple interaction with an AI application, specifically a sales buddy application used by an organization X. As a user, I wanted to ask a business question related to the sales performance. For example, provide a 6-month sales trends analysis, highlight the key external factors affecting sales performance, and recommend data-driven actions to improve the sales growth by 5% in the coming months. Now, from the user's perspective, this appears to be a single request. However, internally, the AI system must understand the user's intent, identify the required data sources, interact with multiple agents and subsystems, analyze various business factors, and then generate a meaningful response. Before proceeding, let's recap how the high-level application architecture looks before and after MCP. So at the left side of the screen, pre-MCP architecture is given, while the right side of the screen, post-MCP architecture is given. Let's understand both one by one. Pre-MCP framework. We can see that the every call to the external tools, agents, and APIs was orchestrated as a part of the application logic itself. This means that the programmers needs to explicitly write codes to invoke various agents and tools and then compose the responses received from them. Post MCP framework, MCP model context program takes on the responsibility of managing calls to various tools based on the requirement without the need of for the explicit coding. This simplifies integration, enhances development speed, and provides a high degree of scalability. At the same time, it also helps compose the responses from the multiple agents and tools before passing them to the end user. Scalability here stands for you can connect to any number of external tools to get the specific task done. Components overview. Let's take a deeper look into the MCP runtime architecture and understand how it powers modern AI systems. The MCP architecture is built around several keys components, each playing a critical role in enabling intelligent, scalable, and connected AI workflows. Let's explore each components and its significance. Host, the central application that receives user input and orchestrate the overall MCP workflow. Agent planning routing, the LLM driven components that interacts that interprets user input and breaks it into the executable task with routing decision. MCP client, interface components that connects the host to the MCP server and help to manage request and response communication. MCP server, service endpoint that exposes tools, data sources, and capabilities for execution of the specific task. Different transport protocols, communication methods, e.g. HTTP, WebSockets, gRPC that enables data exchanges between MCP components. External systems or tools, third-party or enterprise systems, APIs, databases, services that perform specialized operations or provide data. Context memory. The context memory layer stores, manages, retrieves, and updates information that AI agents needs across interactions, workflows. Basically, it helps the AI system remember previous conversations, user preferences, task history, tool outputs, retrieve documents, agent states, business context. Now, there may be a question which tool can be used to serve as the context memory. We generally use VectorDB, example Pinecone or ChromaDB uh, to serve for context memory. The last but not the least in the list is the response composition, the final stage where output from multiple sources are synthesized into the coherent user-friendly responses. We'll discuss in details about each components in details in coming slides. So MCP runtime architecture request routing. Now let's understand how these components interact with one another to form the complete MCP framework. To make it easy to understand, let's break it down into two parts. Part 1, request routing. Part 2, response generation. Let's discuss about the request routing. The host receives a query or a command from the end user as, as mentioned into the picture, which is first processed by the agent planner or router, the LLM powered components. The primary role of the agent planner is to analyze the user input and decompose it into the appropriate executable task. In our example, the agent planner identifies three distinct tasks from the query. The number one, extract sales trend data from the sales tables. Number two, fetch weather data using the external APIs. And number three, invoke a forecasting and recommendation engine. Three tasks are then routed to three different tools or agents via their respective transport protocol and MCP client server connections. In this case, three different MCP server is being invoked to get these informations. Number one, to get the sales trend, sales intelligence MCP server is being invoked. To get the external factors, weather data, external intelligent MCP server is being invoked. Number third, to get forecasting and recommendation information, forecasting and recommendation engine MCP server is being invoked. These MCP server then interacts with their respective agents and tools to process the required information. One of the key strengths of MCP is it is transport protocol agnostic, hence allowing it to work seamlessly across different transport mechanisms without requiring explicit coding for each of them. Now let's zoom in on the response generation part. In this stage, MCP server sends back the processed information from the respective external tools to the host application using their respective MCP client and transfer protocol. This information is then passed through a context aggregation layer. This is context aggregation layer, which consolidates responses from all MCP servers before forwarding them to the response composer. This is the response composer to generate a coherent final output for the user. Additionally, we should not miss to understand the importance of context memory layer, which plays a very crucial role to make the overall system from stateless to stateful. Context memory is a mechanism to store the conversation, used instructions, and histories to ensure continuity, coordination, and reasoning over time. MCP Runtime, the complete architecture. Now, this is the complete end-to-end architecture of MCP. I have tried to explain it in a very simple layman's term. Many developers, even those working on MCP, don't have a clear understanding of how the MCP components are connected to each other. After watching this presentation, I hope there won't be any more confusion. So from now on, whether you are participating in any MCP discussion or solution design, please keep this architecture at the top of your mind. It will help you design, build, and deliver an intelligent, cost-effective, and secure AI system. Lastly, I would like to thank you for your interest in watching this presentation. If you found it interesting, kindly share it with your friends and colleagues who are having the enthusiasm in AI. Also, please suggest if you would like to understand any other topic. See you soon with a new topic. Until then, goodbye and thank you.